Okay, let's move along then to our first speaker, who is actually going to give us works for NPL, the National Physical Laboratory, which holds the standards and measures everything. And one of the things they measure is time. And they've been funded to set up a thing called the National Timing Centre. And so to tell us all about that, we've got their head of the National Timing Centre, which is Dr. Leon Lobo. So, Leon, can I ask you to bring your camera and microphone up, please?
Brilliant.
Fantastic. Good. That's good. We can hear you. I'll hand over to you, Leon, to tell us about the National Timing Centre.
Excellent. Thank you very much, Richard, and good afternoon, everyone. Yes, so the National Timing Centre program is now about a year in delivery, but I really need to get as much engagement across sectors as possible on this. So please, apart from Q&A, please also do get in touch should you have any questions after the session. So as many of you know, a lot of our digital infrastructure across sectors is heavily reliant to a large extent on position, navigation, and timing, and particularly global navigation satellite systems. Now, recent reports, this was published about 2 years ago now by the UK government, which is the Blackett report on satellite dependencies for position and timing, effectively raised that there is a huge dependency across critical national infrastructure sectors for satellite-based positioning and timing, but also that our awareness of the dependency is not as good as we'd like. Also, the element of some of the vulnerabilities of the signals in space were raised, particularly with the threat landscape evolving very rapidly around things like interferences, jamming, spoofing, and the like. Now, timing particularly is very much an invisible utility when it comes to our digital infrastructure across the board, whether it is synchronization of the energy grid or telecom and broadcast infrastructures, whether it is traceable timestamping for financial trading, or for emerging applications like smart cities, autonomous vehicle infrastructures, and the like. In the rail industry, in fact, from the point of view of timing, a lot of it actually started back in the day with the Victorian railways, where we used to use solar time in each city, and which drove the need for us to have a consistent time across the UK, which led to Greenwich Mean Time, which is now Coordinated Universal Time, or UTC. Now, what we've got with this program, essentially, it's a 5-year program that we are leading. So NPL is leading this program with several other government organizations. We've got around £36 million, and it was funded by the UK Research and Innovation Organization as a strategic priorities fund, because of the need to secure our timing capability in the UK, based on the dependency across the board. Now, what we've got here is we've got several key objectives essentially for this program, and I'll just rapidly go through this. The first one is around resiliency. So whether it is the element of, as I said, financial trading, the telecom synchronization, or like in the rail industry, the whole element of digital transformation for signaling, for traffic management, movement control, potentially artificial intelligence and prediction for maintenance, or just to enhance the passenger experience, it's going to be quite critical that we understand not just that we have the right time feeding these systems, that the synchronization across the infrastructure is as expected and to the level that we require, but that we understand that these signals have the level of integrity and assurance that is required in order to operate safely. And that's the bottom line, really. It's all about safety for us, for our systems and our users. Now, from the resiliency perspective, what we are doing is at NPL, we manage the national timescale, UTC NPL, and we disseminate that to the UK over a whole range of different methods, whether it's over the internet, over fiber deliveries, over SATCOMs, and RF broadcasts. So what we are doing now as part of this program is essentially securing that core that is the national timescale by putting in place a geographically distributed capability. Our second objective for this program is really about stimulating the supply chain for timing and synchronization capability in the UK. And to that extent, what that is going to be leveraging is we've got a pot of funding available for any activity that could leverage that to develop new products and services in timing and synchronization within the UK. And we partnered up with Innovate UK to deliver those calls and to fund those programs. And then finally, the element around the skills, education, and training piece is something that we've started to delve a little deeper across the board, across industry, across academia, to understand what is in place, what the gaps are, and to start to address those gaps by putting in place CPD training courses, degree level modules, PhD studentships, secondments, and apprenticeships and the like, in order to upskill the capability within the UK. Now, what we've already found out through surveys that we've conducted is that 76% of the respondents have a significant need for timing within their organizations. And 60% of the respondents suggested that they have a significant gap in being able to upskill their personnel because of the lack of some of these courses and degrees, etc. So it is something that we are starting to understand is something that needs to be addressed. So some of the work streams on this front are, you could say, leveraging that engagement in order to put that capability in place within the UK. Now, what we really want from the community and yourselves is to engage not just on your current needs and requirements for digitalization of the rail sector and some of the communication capabilities, the data capabilities as they're getting enhanced, but to raise what you see as the challenges you're facing now, but also for the future. Not just from the point of view of the signals that you have available, but also from the point of view of the resiliency required towards that end goal, which is that safety within the sector. So on that first objective around resiliency, what is currently the national timescale is held at NPL, so the National Physical Laboratory in Teddington. And so the national timescale UDC NPL is essentially a whole host of atomic clocks, which cesium atomic clocks, hydrogen masers, cesium fountain that provides the UK with the realization of the second. And this data essentially contributes to formulation of the global timescale that is UTC, or Coordinated Universal Time, that effectively feeds infrastructures globally. Now, UTC is a paper timescale. The real-time implementation of that and realization is from labs like ours at NPL. What we are putting in place now is essentially a geographically distributed capability on secure sites across the UK, fully meshed up, leveraging everything from fiber, RF, and SATCOMs in order to make the UK our timing capability resilient and secure, such that in the event that any one site went down, the UK would still have that capability in place in order to support our critical national infrastructure sectors. The BIPM essentially is that umbrella organization for the National Measurement Institutes that compute what is that paper timescale UTC. Now, from the innovation piece that I mentioned that we are delivering through Innovate UK, where effectively we've got about 6.7 million to offer to industry and academia to engage, develop those products and services towards essentially stimulating that development of that supply chain for time, frequency references, and dissemination solutions. But what we are also doing is from that resilient core, that is that resilient enhanced timescale infrastructure, we will be delivering these time and frequency references to what we class as nodes dotted around the country. Now, the way we are structuring this is these nodes effectively for the duration of the program will be R&D capabilities, which will offer different sectors depending on where they are placed, whether it's the telecom sector, the rail sector, for example, or the energy sector, with the relevant signals in order to allow that innovation to take place. And we're looking at metrics around the accuracy of the signals, traceability back to the references, but also things like availability, holdover, integrity monitoring, and the like. In order to start to shape what these nodes look like coming out of the program towards potentially scaling up the capability across the UK for critical national infrastructure as well as the emerging applications. And what we are doing right now in this, at the end of this first year, or towards the end of this first year of the program, is essentially the engagement piece. Talking to end users, talking to government, to start to pull out these needs and requirements and challenges. Because in many cases, the easiest solution to date that is implemented is a GNSS solution, so leveraging GPS, but that's not necessarily the requirement from the point of view of either accuracy, availability, integrity, security, and the like. So we're trying to develop this such that it is not only viable for the applications of today, but will be able to address the applications of tomorrow and those challenges. So we really, really need your help to form these, to structure these such that you get maximum benefit from this. And then, as I said, from the skills piece, apart from the engagement, the surveys that we've been conducting, it is now about structuring what essentially is going to become a training blueprint for the UK for timing, in order to start to develop those courses, those degree modules, to enable that capability within the UK ecosystem across the board, whether it is government, whether it is industry, whether it is academia, and particularly trying to get an understanding of those challenges in those future applications. That's primarily it. So please do engage. Please let us know what you need, both now and for the future, around the timing, the frequency, the dissemination, and the security of that, in order to help shape what the outcome is going to be and potentially that scale up beyond the 5 years. That's it for me. Thank you very much. I'm open to questions now.
So thank you, Leon. I'm going to have to stop myself, but I'll allow myself just one. That's very timely. Right. So audience, open for you to push in your questions now. I've got a slightly different interface to you, so I sent you a message just now talking about a pop-out tab and so on. Apparently, you've got a very, very obvious questions box. So just click on the questions tab, bang in your question, and get that sent to us. So meanwhile, I've got a question from Doug Green, a very experienced signaling person who's a RIA member over many years. So he's asking Leon, how resilient is our timing centre in the UK from another Carrington event? I don't even know what that is, so perhaps you can explain what a Carrington event is.
Yeah, so essentially, Carrington events are solar storms, effectively, that could take out our satellites. Now, the timing capability in the UK, as it stands, because it is based on clocks on the ground, it is very resilient to such events. However, the communications from these devices, as well as the element around some of the UDC formulation piece, is based on transfer of signals and data using SATCOMs and even GNSS to that extent. So what we are planning on putting in place, especially the element of that Red Sea infrastructure, the resilient enhanced timescale, is about ensuring that we use multi-modalities of dissemination. So not just SATCOMs, but also fiber in the ground, RF potentially, in order to ensure that we don't have a single failure mode, or the failure modes are very, very disparate, in order to maximize the resiliency. So it's not about a silver bullet solution, but it is about ensuring that we have multiple modalities in order to ensure resilience. I hope that answered the question.
Well, I hope so too. Perhaps Doug, you can give us some feedback on that, or a supplementary question. So, what sort of incidents are we talking about here? Earthquakes?
Oh no. So these are essentially solar storms. So things like sunspots and the like that cause emissions in the direction of the Earth that could take out satellites. And we are heavily reliant currently, from a position navigation and timing perspective, on the likes of GPS and potentially Galileo. And it is about ensuring that we build into our infrastructures resilience in the event that the satellites are taken out, or the signals are affected, either inadvertently, naturally, as in Carrington events and solar storms, or maliciously, like jamming and spoofing. Jamming being denial of service, and spoofing is where the signals are altered, okay, which are much harder to detect as well.
We have a great thing in signaling where we have diverse systems like this, and they tend to have voting mechanisms. Sometimes you have a 3-channel system and you'll have a 2 out of 3 voting mechanism. That's one thing we used. And Doug comments and said, it sounds like the diversity is good. James Little adds in, how do we determine the truth in terms of different times? Who wins out and where's the actual truth in this?
Yeah, it's a typical question. You have one clock, you've got the time, you've got 2, you don't know which one is right. So the aim is to have multiple sources, but also have that traceability. You can have a timing system, but you need to understand the traceability back to the reference. And if you have any break in that chain, you've lost that traceability. And having an understanding of that whole traceable chain back to the reference that is UDC gives you that confidence in that your signals are correct. Also, the overarching layer around monitoring and that integrity piece is going to be crucial. So the NTC as the resilient capability for the UK timing and the timescale, in addition to that, by virtue of putting out these nodes, will allow us to deliver those timing references, but almost create a sensor network to some extent where we could monitor signals in space for integrity and essentially create things like health maps for GNSS for the UK to support applications that are leveraging GNSS in those locales.
Okay. I mean, have you actually seen much uptake from the rail industry yet? Are you getting inquiries and discussions with organisations?
Yes, so we've had some discussions with Network Rail, very high level, and I believe that the current implementations, particularly for timing, are not as crucial because it's very safety dependent. So it's maybe for non-safety, non-liability type cases. But the element around the digital transformation piece, the communication, whether it's train to train, where we're looking at any other smart infrastructure, digital signaling, the passenger experience, all the systems, the synchronization of the systems is dependent on timing. And ensuring that capability is resilient is going to be quite crucial for the future. And leveraging alternative sources that can provide you with that assurance. So the element of assurance is going to be quite important to implement on that front.
Yeah, I mean, that's a good observation that traditionally in rail, well, since the onset of GPS, there's been a decision to not use GPS for safety critical applications in signaling and control and so on. But increasingly, we're seeing GPS applications or GNSS applications creeping into the industry in all sorts of other areas.
Yeah.
When you kind of add together the effect of all of those, it's now getting quite large on the industry, so that we can't afford to be without the accurate timing, for example, that we get from such satellite systems.
Yes. And essentially, so any GNSS system is essentially sourced from based on timing signals. So you're essentially trilaterating your position based on the signals that are from the satellites. But those signals effectively come from a lab like NPL. In the case of GPS, is UTC, USNO, the US Naval Observatory. And what we are trying to put in place in the UK is access directly to those signals in a resilient fashion for timing, rather than through a vulnerable space route effect.
You would hope that as an industry which carries responsibility for people's safety, that we would adopt the kind of technology which, for example, I understand this is used in the financial services sector and around high frequency trading, where large amounts of money changes hands in microseconds.
Yeah.
Is that a big market area for you, high frequency trading?
It is. So more importantly now, as of January 2018, in the financial sector, is a regulation that kicked in called MiFID II, or Markets in Financial Instruments Directive, where they mandated the element of timestamp traceability for all reportable events. So anything that is reportable, whether it's transactions or anything else, has to have a timestamp traceable back to UTC to within, in the case of HFT, it's 100 microseconds to UTC. And they need to demonstrate that. And what that has, it's completely transformed this is across Europe, it's completely transformed that sector from the point of view of market clarity, for one. So you know who's done what and when, but also aids in essentially making the market more efficient, as well as providing forensics to the regulators in the event anything like a flash crash occurs. Because suddenly now you can actually compare order books from different venues, whereas previously it was always a gray area because you couldn't match them easily.
Yeah, that's interesting.
That's the regulatory drive, yeah. Sorry, Richard?
No, I was just going to say, it feels to me like the correct time is an asset throughout the industry. It's perhaps not the very physical kind of thing we'd regard as an asset normally, but it is something that needs to be correct, it needs to be maintained, and so forth. And that as we move towards more automated systems, so trying to draw a parallel here with high frequency trading, as we move towards more automated signaling control systems, which you'll hear about from other speakers during this afternoon, actually, what happened when, or what's happening when in the current tense, and what happened when in the past tense, if we're replaying an incident or something that's either gone well or gone wrong, to find out what the elements were that made that happen and when they happen, then timing is absolutely key. Great. Okay. So can I encourage people to engage with you as well, Leon, if they I can't remember, did you put some contact details in your any of your slides?
Yeah, it's on the slide that's up at the moment. So please
Okay.
do engage. Please do get in touch. Any application that you feel requires an assured capability for timing, let us know, because we can accordingly structure what we are doing to support that.
Yes. Sorry about that. Screen real estate. I've managed to cover up your email address with my question box. Okay, so I definitely encourage members then to get in touch with you to discuss this.